Hello my dear friends, how are you all? I hope you all are fine. So you are very welcome in our lecture number 4 of introduction to graphs. Okay, so I hope you will enjoy this lecture. So this lecture is going to be very amazing, so you have to be listen very carefully. Okay my dear friends, yes, now let's start without wasting the time. Yes, so today here we are going to discuss about a line graph. What is? Yes, now what is line graph? Here we are going to see. Okay, so basically a line graph is one that is used to plot data that changes over a period of time. Okay, so in this again we are going to plot a data on the graph, okay, that changes over a period of time. Okay, a line graph is a unique graph which is commonly used in statistics. Okay, this is a very unique graph. I hope you get this point, my dear friends. So in this, here you can see that it represents the change in a quantity with respect to another quantity. Okay, in this it represents the change in quantity with respect to another quantity. If you see the example, for example, the price of different flavors of chocolates varies, which we can represent with the help of this graph. Here, the price of different flavors of chocolates varies. Okay, understand, my dear friends? So this is all about the line graph. Okay, so in this variation is usually plotted in a two-dimensional xy plane. Okay, if the relation including any two measures can be expressed utilizing a straight line in a graph, then such graphs are called linear graphs also. Thus the line graph is also called linear graph. What? Yes, linear graph. Yes, now if you see the example, here is, now you can see we have a time and we have a temperature. It means we are going to see the relation between time and temperature. Okay, and we are going to draw a graph. So first of all we are drawing a graph like this. Okay, on the x-axis we are representing the time and on the y-axis we are representing the temperature. Okay, so time is what? 6 a.m., 10 a.m., 2 p.m., 6 p.m. Okay, so you can see 6, 10, 2 p.m. and 6 p.m. Okay, so this is what? This is the time. Now the temperature is what? 37, okay, 40, 38 and 35. Okay, so here is, if we represent this, at the time of 6 a.m. temperature is 37. So at the time of 6 a.m. temperature is 37. So this is the first point. Okay, and the next one is at the time of 10 a.m. temperature is what? 40. Temperature is 40. So this is the point. At the time of 2 p.m. temperature is 38. Temperature is 38. Okay, and at the time of 6 p.m. temperature is 35. So if we join these points we get a line. So this is what? This is the line graph. This is the line graph, and you can see that between, here is between 6 to 10. Okay, between the time 6 a.m. to 10 a.m. the time is what? The temperature is what? Temperature is increasing. Temperature is increasing. And between 10 a.m. to 6 p.m. temperature goes down. So this is what? This is a line graph which shows the changes over a period of time. Okay, understand, my dear friends? Okay, so basically we can say that it is a chart which shows joining the points. Okay, then we can make a line graph. Understand? Okay, understand. Now let's move on. Now here we are going to see the types of line graph. Types of line graph. Yes, now first type is simple line graph. What is simple line graph? Now in this, only one line is plotted on the graph. Only one line is plotted on the graph. Okay, now the second one is multiple line graph. So in this, more than one line is plotted on the same set of axes. A multiple line graph can effectively compare similar items over the same period of time. Yes, now let's see vertical line graph. So what is vertical line graph? In which vertical line graphs are a graph in which a vertical line extends from each data point down to the horizontal axis. Here you can see that. So vertical line graph sometimes are also called the column graph, and in which a line parallel to the y-axis is called the vertical line. It is simple. Simple definition is that a line parallel to the y-axis. Here you know that this is the y-axis and this is the x-axis. Okay, so the vertical line is what? This is parallel to y-axis. Okay, so this is the vertical line graph. Yes. Now let's see the horizontal line graph. Now in this, horizontal line graphs are graphs in which a horizontal line extends from each data point which is parallel to x-axis. Okay, so horizontal line graph, sometimes also called a row graph. Sometimes also called a row graph. Got it? So a line parallel to the x-axis is called a horizontal line. A line which is parallel to, yes, parallel to x-axis. Here you can see that this is what? This is our horizontal line because it is what? It is the parallel to x-axis. Okay, so here this is what? This is y is equals to b. Okay, b is the distance from x-axis to y-axis. Okay, and similarly here is x is equals to, we can write a. So a is the distance from y-axis to x-axis. Okay, so this is constant. Okay, this is equidistance from y-axis. That is why we are saying that this line is parallel to y-axis and this line is parallel to x-axis. I hope you understand these things, my dear friends. Yes, now let's move on. Now here is, now how to make a line graph. This is very important. So if we have created data table, then we draw linear graphs using the data tables. Okay, so these graphs are plotted as a series of points. Okay, first of all we have to plot the point that we have to join. Okay, which are later joined with straight lines to provide a simple way to review data collected over time. So this is not a big deal to draw a line graph. So it offers an excellent visual format of the outcomes data collected over time. Okay, understand? Yes. Now here we are going to see the straight line graph. So a line graph is a graph formed by a segment of a straight line that joins the plotted points that represent given data. That represent what? Given data. So the line graph is used to solve changing conditions, often over a certain interval of time, or we can say certain time interval. Okay, a general linear equation function which has the form like y is equals to mx plus c. So this is a general linear equation form. Okay, where m and c are what? This m and c are constant. So the fundamental rule to the rear of sketching a linear graph is that we require only just 2 points to graph a straight line. Just only 2 points. Okay, so to plot a linear, or we can say line graph, there are following some steps. Here you can see that first of all, use the data from the data table to choose a suitable scale. And then draw and label the scale on the vertical, means y-axis, and horizontal, which is x-axis. Got it? So list each item and place the points on the graph. Got it? Now join the points with the line segment, so we get a line, or we can say linear graph. Okay, here you can see that first of all we have to draw the axes, then we have to represent the points on the x and y axis respectively, then we have to plot the point, then we have to join the line segment, so we get a linear graph. Now if you talk about the double line graph, so in a double line graph is a line graph with two lines in a single graph with the same graph. Okay, so a graph that compares two different subjects over a period of time, then we have to use the double line graph. So a double line graph shows how things change over a period of time, basically. So the double line graph shows what? Two lines graph within one chart. So in one chart there are two lines, means there are double lines. Got it? So double line graphs are used to compare trends and patterns between two subjects. Okay, now here is steps to make a double line graph. So similarly, we have to use the data from the table to choose an appropriate scale. So draw and label the scale on the vertical and horizontal axis. So list each item and locate the points on the graph for both the lines. Then connect the points with line segments separately of both the lines. Okay, then draw the line graph within one chart. Then draw two line graph within one chart. Okay, so here you can see that. So if you observe this, we have two line graph, we have two lines. Okay, yeah, so these are the what? These are the line segment. These are the line segment. Okay, so with the help of line segment, the line graph can be drawn. Okay, so there are two lines which represent the two sets, which represent the, yeah, here city 1 and city 2. There are two products we are using. We have to show, we have to compare. Okay, so this is what, this is average monthly rainfall. Okay, and on the x-axis we have January, February, March, means we have month, and on the y-axis we have the data. Got it? So we are going to compare the rainfall of two cities. So that's why we are making the two lines, first one and second one. Okay, so this is what, this is double line graph. This is double line graph. I hope you understand these things, my dear friend. This is very simple. Yes. Now uses of line graph is what? The important use of line graph is to track the changes over the short and long period of time. Okay, this graph is used to track the changes over the short and long period of time. So it is also used to compare the changes over the same period of time for different groups, for different groups. It is always better to use the line graph than the bar graph whenever the small changes exist. Whenever the small changes exist, then it is better to use the line graph instead of bar graph. Okay, understand? Yes. Now, for example, in a company finance team wants to plot the changes in the cash amount that the company has on hand over time. In that case, they use the line graph plotting the points over the horizontal and the vertical axis. So it usually represents the time period of the data. Okay, yes. Now let's solve some problems. So here is, now the following graph shows the temperature of patients in a hospital recorded every hour. Okay, so on the x-axis we are plotting the time, which is 9 a.m., 10 a.m., 11 a.m., 12 noon, 1 p.m., 2 p.m., 3 p.m. Okay, and on the y-axis we are going to represent the temperature, like we are starting from 34. Okay, so 34, 35, 36, 37, 38 and 39. So this is what, this is the temperature. So the graph shows what? The graph shows the temperature of patients in a hospital, which is recorded in every hour. So it means here you can see that at 9 a.m. the temperature recorded is what? The temperature recorded is, here is 35 and here is 36, and it is a midpoint, so here is 35.5. Okay, at 10 a.m. the temperature recorded as 36 degrees centigrade. Okay, at 11 a.m. the temperature recorded as 39, and so on. Okay, so now here we have some questions, which is that what was the patient's temperature at 1 p.m. Okay, so we have to see that what was the patient's temperature at 1 p.m. So here is, you know that this is what, this is 1 p.m. Okay, this is 1 p.m. So here is, this is the point, so it shows the temperature here is. Okay, so now this is what, this is in between 36 and 37, so it means it is what, 36.5. Okay, so here we can write it as, so the patient's temperature patient's temperature was 36.5 at 1 p.m. Okay, at what? At 1 p.m. Now the next question is, when was the patient's temperature 38.5 degrees centigrade? Yes, so you can see that 38.5 is here, 38.5 is here. So if you draw a line, which means that at point, okay, so now if you draw a line parallel to y-axis, so it goes to the x-axis at 12 noon. At what? At 12 noon. Okay, so we can write the patient's temperature was 38.5 degrees centigrade at 12 noon. At what? At 12 noon. Okay, simple. Now the next question is, the patient's temperature was the same two times during the period given. So what were these two times? So if you observe this, here is, you can see that at 1 p.m. temperature is 36.5, and at 2 p.m. also temperature is again 36.5. Okay, so we can write the patient's temperature was same at 1 p.m. and 2 p.m. Okay, yes. Now the next one is, what was the temperature at 1:30 p.m.? Okay, 1:30 p.m. How did you arrive at your answer? So here is, we have to tell that what is the temperature, what was the temperature at 1:30 p.m. So first of all, we have to locate 1:30 p.m. So here is, you can see, here is, if you observe this is 1 p.m. and this is 2 p.m. Okay, so this is what? The midpoint of this is what? 1:30 p.m. What? 1:30 p.m. Okay, now if you move parallel along the y-axis, parallel to the y-axis, so here it cuts the line at this point, and this point, if we move parallel to the y-axis on the x-axis on the y-axis, then it cuts the point at which point? Here is this 36.5. What is 36.5? Okay, so at 1:30 p.m. temperature was 36.5. So we can write at 1:30 p.m. temperature was 36.5 degrees centigrade. 36.5 degree centigrade. So it is saying that how did you arrive at your answer? So here on the x-axis between 1 and 2, we have the middle part, which is 1:30 p.m. and this point is equidistant from 1 and 2. Okay, and if we move along the y-axis, okay, so we get a point on the line. Okay, and we have, from this point we have to move along the x-axis and we reach on the y-axis at particular point. So this is point which lie between 36 and 37, which is equidistant from both the points. So this is what? 36.5. I hope you get this point. Yes. Now the next one, here you can see, next is, during which period did the patient's temperature show an upward trend? Okay, so if you observe this, during 9 to 11 a.m. the patient's temperature shows the upward trend. Okay, here you can see during 9 to 11, and during 2 to 3 the temperature shows the upward trend. So here we can write the patient's temperature show an upward trend from 9 a.m. to 11 a.m. and 2 p.m. to 3 p.m. Okay. Yes, now the next question is, here is, you can see that the following line graph shows the yearly sales figures for a manufacturing company. So here you can see that on the x-axis we are representing the years, and on the y-axis it represents the sales, which is in crores. Okay, got it. Now it is asking that, here is, what were the sales in 2002 and 2006? Got it. So here if you observe this, the sales is in 2002 it is 4 crores. Okay, and the sale in 2006 it is what? It is 8 crores. So here we can write first in sales in 2002 was 4 crores. Okay, so this is rupees. And in the second part, so sales in 2006 was rupees, here is rupees 8 crores. 8 crores. Got it? Yes. Now next is what were the sale in 2003 and 2005? Here if you observe this, in 2003, if you match this, here we have, it is a point between 6 and 8, and this is what? This is 7. So we can say the sales in 2003 was 7 crore rupees, and similarly in 2005, here you, if you observe this, if you meet the point, okay, so we get 10. So we can say the sales in 2005 was rupees 10 crores. Okay, so in the first point we can write the sales in 2003 was rupees, here is rupees 7 crores. Okay, and in the next one is the sales in 2005 was rupees 10 crores. 10 crores. Okay, this is the answer. I hope you understand these things. Yes, now the next one is, now compute the difference between the sales in 2002 and 2006. Yes, now if you observe the graph, here we can say that, here we can see, here is, in 2002 we know that the sale was 4 crore rupees, and in 2006 the sale was 8 crore rupees. So we have to find the difference between them. So here is the difference between the sales in 2002 and 2006. So this is, here is rupees 4 crores minus rupees 8 crores. Rupees 8 crores. So this is what? This is 4 crores. This is 4 crores. Okay, so this is the answer. Yes, now the next question, here you can see. Now in which year was there the greatest difference between the sales as compared to its previous years? Now if you observe this, the sales in 2005, we know that this is what? This is, here you can see, this is 10 crore rupees. And the sale in 2004, this is what? This is 6 crore rupees. And if you subtract this, if we subtract 10 minus 6, we get 4. So we can say that in the year 2005. Okay, there was the greatest difference. There was the greatest difference between the sales. Okay, and if you compare to its previous year. Okay, which is, here you can see, which is rupees, here is 10 crores minus rupees, here you can see rupees 6 crores. So here we get rupees 4 crores. Okay, so this is the answer of this question. Okay, my dear friends. Yes, now the next one, here you can see that for an experiment in botany, two different plants, plant A and plant B, were grown under similar laboratory conditions. Okay, and their heights were measured at the end of each week for 3 weeks. Okay, here you can see on the x-axis here is the weeks, and on the y-axis here is the height, which is in centimeter. Now the results are shown by this following graph. Here if you observe this, here we have double line graph. You can see that we have a line for plant A and we have the another line which is for plant B. Got it? So we have a comparison between plant A and plant B. Now here if you observe this line represents the plant B and this dotted line represents the plant A. Okay, so now here is in the first week. Here you can see in the first week the height of plant A is, here you can see height of plant A is 2 centimeter and height of plant B is what? This is 1 centimeter. This is what? This is 1 centimeter. Got it? Now at the point 2, it means in the second week the height of the plant A and plant B is same, which is, you can see, which is 7 centimeter. And in the third week height of the plant A is 9 centimeter. If you see that this is represent like this is 9 centimeter. Okay, and height of plant B is 10 centimeter. Okay, now here we have some problems which is now how high was plant A after 2 weeks and after 3 weeks. Got it? So after 2 weeks plant A is of 7 centimeter. Okay, and after third week plant A is of 9 centimeter. So we can write in the first part plant A was 7 centimeter after 2 weeks, and here is in second plant A was, here is plant A was 9 centimeter after 3 weeks. Okay, yes. Now in the next one is, here is next part is how high was plant B after 2 weeks and 3 weeks. Okay, so now in this case here is in the first part, so we can write plant B was, here you can see in 2 weeks, after 2 weeks, here is plant B is what? Similar to plant A, which is 7 centimeter. So we can write plant B was 7 centimeter after 2 weeks. Okay, now in the second part, if you observe this, it is 10 centimeter after 3 weeks. We can write plant B was 10 centimeter after 3 weeks. Okay, yes. Next question is how much did plant A grow during the third week? during the third week. Now if you observe this, plant A in the week of third, during the third week, this is starting from here, this is 7 centimeter and this is 9 centimeter. So we can write plant A grew, here is 9 centimeter minus 7 centimeter, which is equals to 2 centimeter. We can write 2 centimeter during third week, okay, this is the answer. Yes, now next one is, yes, now how much did plant B grow from the end of the second week to the end of the third week? Here's the question is similar, but here is the plant B. Okay, so we can write plant B grow from the end of the second week to the end of the third week, which is here, you can see, which is here is, you can see at the end of second week the height of the plant B is what, this is, you know that this is 7 centimeter, and at the end of the third week the height of the plant B is 10 centimeter. So this is 10 centimeter minus 7 centimeter, so this will become 3 centimeter. So the result is what, 3 centimeter. Okay, yes, now next question is, during which week did plant A grow most? The plant A grow most. So if you observe this, here is during second week plant A grew the most. So we can write plant A grew highest during second week. During what? During second week. And in this case, during which week plant B grow least? Here is, it is asking about the least. So if you observe this, during first week, here is during first week plant B grew least. So here we can write plant B grew least during first week. Okay, understand my dear friends? Yes, now the next one here you can see, were the two plants of the same height during any week shown here? Specify. So this is very easy, so we can write here is yes. Okay, so at the end of second week the height of the plant A and plant B is same, which is 7 centimeters. So we can write yes, at the end of second week the height of plant A and plant B is same, is what, is same, which is what, which is 7 centimeter, which is 7 centimeter. Okay, yes, now the next question here you can see that the following graph shows the temperature forecast and the actual temperature for each day of a week. Okay, so this dotted line represent the forecast and this continuous line represent the actual temperature. Okay, so again we have double line graph, okay, so here you can see that on Monday the temperature of forecast is, here you can see this is 15 degrees centigrade, and the temperature of actual is what, this is, yeah, here is, this is in the middle of 15 and 20, so this is what, 17.5 degrees centigrade we can say. Okay, and so on. Similarly we can compare, we can see the actual temperature and forecast temperature with the help of this graph. Now there are some problems. Okay, so what is this? On which days was the forecast temperature the same as the actual temperature? Okay, on which days? So when the points of forecast temperature and actual temperature is coincide, then we can say that at that day the temperature of the forecast and the actual temperature was same. Okay, so you can see that this point is coincide, this point is coincide, and this point coincide, and here you can see this point is coincide. So we can say on Tuesday, Friday and Saturday the forecast temperature was the same as the actual temperature. Okay, so here we can write it as on Tuesday, Friday, on Tuesday, Friday and Sunday the forecast temperature was the same as the actual temperature. Okay, understand, my dear friends? Yes, now the next one is, what was the maximum forecast temperature during the week? So if you observe this graph, the highest temperature, the highest point is represent the 35 degrees centigrade. So we can write it as the maximum forecast temperature during the week was 35 degrees centigrade. What is 35 degrees centigrade? Yes, next one is, here you can see, what was the minimum actual temperature during the week? Okay, if you observe this, the minimum actual temperature during the week was, here you can see, this is 15 degrees centigrade. After reading this, so here we can write the minimum actual temperature during the week was 15 degrees centigrade. What is 15 degrees centigrade? Okay, now the next one is, on which day did the actual temperature differ the most from the forecast temperature? If you observe this graph, the maximum gap between the actual temperature and the forecast temperature is this. By what? By, here is the forecast temperature is what? The forecast temperature is, here you can see, this is the middle of 20 and 25. Okay, so here is 22.5 and this point represent is 15. Got it? So this is the maximum gap between the actual temperature and the forecast temperature. So we can write it as, and this day is what? The day is Thursday. So we can write it as the actual temperature differ the most from the forecast temperature on Thursday. On what? On Thursday. Okay, understand, my dear friend? So this is enough for today. Okay, and this is all about the line graph. I hope you understand these things. So now, my dear friends, thank you very much for listening me, and we will meet in the next lecture with the next amazing topic. Okay, so bye bye and take care.